One. Right, greetings everyone. Welcome to another MetaNet monthly ICU online meeting. I can't actually remember which number this is. This is something like the 9th or the 10th meeting, possibly more. We are going to be talking about Scrypt today primarily, and then we will be talking about Scrypt, a little bit of Scrypt into compilers, topologies on the MetaNet, businesses in collaboration, and identity management. If you have any questions, please type them. If you wish to speak, I shall unmute you. Type that you wish to speak and ask a question, and I shall unmute you. Thank you very much, everyone. This is recorded. Over to you. Sorry.
I can go.
So I'll give you a quick intro as well. You can pronounce. I'm terrible with name pronunciations, but okay. Shirley is from Scrypt, and you'll have to correct my terrible pronunciation. And Scrypt is, well, you can explain Scrypt. Scrypt uses script language properly and is one of the first proper groups which is using a compiler and bringing it out to the wider public. Okay, over to you.
Yeah, hi everyone. I'm Stefan, Constantinos, and Parisa. Hi everyone. How's the lockdown going? I hope everybody is safe and sound and trying to remain calm. I mean, it feels like a weird timing. And so thanks for the invite, Joe. We talk about a little bit in London, and very nice talk. So today I'm very pleasure to be invited here to talk about more about Scrypt. So I think some of them may already heard about it, but for people who have never heard about it, so Scrypt is it's a high-level language. It's kind of like a JavaScript or Solidity. It is used primarily to write smart contracts on Bitcoin platform. So basically, it's a high-level abstraction on top of the so-called Bitcoin script. Basically, it's a native language. So whatever you can think of is just like a syntactic sugar. So whatever Scrypt can do, you can use Scrypt to do it, but it's just much simpler because I don't know about you. I mean, maybe Parisa, he can use Scrypt directly, but I think most of the people, even for me, I would rather to write something similar to like a more modern language, like a JavaScript. So that's the whole point why I have the Scrypt here. So I think today, I think as also John talked about in the ICU a little bit, so mostly to talk about some of the articles I have released recently. So basically the idea is since now we kind of have a more or less stable and more, I would say, quite featured language, basically. So I want to introduce, so to show some of the examples how people can use this, because I think there's quite a misunderstanding. Even I would say even within BSV community, people don't get a sense or what kind of things can be achieved by Scrypt and by extension Scrypt. So I want to basically I want to show some demos, and I want to convince people even within our community it can do actually anything. Is truly unlimited. So the only limit is your imagination. So I put the series articles. I think I also shared a link here in the chat. So if you can click in, I think for people, maybe some people may already read some of it, but if you are interested in Scrypt or Scrypt or smart contracting on Bitcoin in general, I strongly recommend to go through some of these articles. I think it's very fascinating. It achieves a lot of things, quite a few things that people thought were not impossible before. So I feel very excited about this. So today I want to briefly just go over high level what these articles are and what they have achieved. And I think maybe brainstorm a little bit what's coming next for Scrypt. And I want to hear some feedback from you guys or the community. Anytime you have questions or comments, whatever, just feel free to interrupt. Okay.
I'm just going to throw in here for the viewers and people listening. Scrypt is a primary language. It's a base language which can be compiled and used together to make higher programming languages. It can be compiled in different ways to create different types of higher programming languages. Scrypt is something I personally have been really looking forward to. Scrypt being one of the first to build it together in a decent higher programming language. I highly suggest people have a look at it and have a read through the article, which is in the chat. It's linked in the chat, and I'll put it on Twitter as well.
Documentation too.
Yeah. So eventually there will be more higher programming languages, compilers, but Scrypt are taking the lead. So as one of my common sayings
so far
is,
it's only player in this field, so it's kind of in a unique position right now. So hopefully, as the people understanding more about the Bitcoin's smart contracting capabilities, more people will develop a new language, I hope. But I want to get it started. But of course, I want people to use my language, so that's a bias here.
Absolutely right. I mean, it's an amazing job you've done. Sorry, can you describe some of the wonderful things that you can do, that you condensed for users to be able to do?
Okay. Yeah, so after CoinGeek London, after I introduced, basically when you have a modern language, there are quite a few pieces you want to have together. One is, of course, you need basically the compiler, right? And then you need a fully featured IDE, which I released at CoinGeek London. So basically, it's for people who have a programming background, it's an extension of one of the most popular IDE platform out there called the Visual Studio Code. So basically, you go to the extension marketplace. If you search Scrypt, and then you click one button, and then you are ready to go. So basically, after CoinGeek London, we have this IDE ready. So now people can just use it's like a normal workflow for other languages. So then the next question people usually ask me is, what can I do with this language? What kind of contracts you can write? Because in general, because a lot of the people, even as I said, in our community, they don't fully understand what is the capabilities are, mostly because nobody has done it, and also because of the Bitcoin Core and other people, they're already always been repeating, I don't know, the misunderstanding or misconception. Oh, the Bitcoin cannot do this A, B, C. Bitcoin only can be used as money, right? So that's why the rationale behind this series of articles. So basically, I'm now briefly introduce what they do on a high level, and then I welcome any feedbacks. So basically, I have a series of articles here based to give just first glance a teaser of what can achieve. I think the feedback so far from the community, which I'm very thankful, is being very positive, and a lot of people are reading and giving me feedbacks. So basically, you can show a lot of things. For example, I did the first stateful smart contract on Bitcoin. So basically, previously, if somebody has misfortune like me to read the Ethereum white paper, so on one of the reasons say, why the Bitcoin cannot do smart contracts is because it cannot maintain state. So exactly what I did here. So basically using some tricks. So that's the number one trick here is in my first article. So basically I call like, it's almost like opcode. If you know about Scrypt, it's called op push transaction. So basically this primitive is a very nice trick that's invented by Ainchain a few years ago. So basically, I just used this trick. So what does this trick do? So basically, if you know the Bitcoin script, so basically you have a login script, you have unlocking script, right? So, and the script is all wrapped up in a transaction. So basically using this technique called op push transaction, it lets you inside the script, you can know your context. You can know the transaction you are within. So it's kind of like almost like a reflection in general programming languages. So basically, let let the script not only know what's on the stack, what's on the script, but also what's the transaction look like. So once you can know the transaction, you can do a lot of things actually. So with this powerful primitive, I give a few examples. It's all extension. So for example, in the state transaction, state for contract, what I do is, so because you can know the whole transaction, which includes all the inputs and all the outputs, so you can specify what outputs conditions must be met to spend the coins. Because usually before, when people think about the Bitcoin contract, you have locking, you have unlocking script. So people usually think, oh, you can only satisfy, you can specify what goes into the inputs, must maybe some public key or signature must match. But here, it enables you not only control the input, but it also specify what are the outputs. For example, you can say, oh, you can redeem this coin only if I pay Joe, let's say 1% of the whole outputs, okay? Which is usually deemed impossible before. So with this, so because you can know the output and all the transaction, so you can also know the previous output, right? So the way I do is, one way to maintain state is to say, oh, I put the state in the output, right? So I say when I spend this output, I make sure the state has to transition to the next output, the current transaction. So that way, you kind of like chain these transactions together, and the state they can evolve. And whatever the rules, you kind of like a finite state machine. So you have state, you have the transitional rules, and the rules is also part of the contract. There's a contract, you have two parts. You have the logic, the code part. You also have the data and the state part. So in this way, I put an analogy, it's like kind of like an object-oriented way. So you can, it's like an object. For each contract is like object. You have methods, you have properties or states. So in that way, you can implement actually any state you want. So that pretty much a subset, a conclusion from there you can reach is, so anything Ethereum or EOS can do, you can do it here today. It's just what we are working on here. Basically, I want to show they can be do and how to do it. I showed it with code, some example code. I also send it to the actual network for actual processing. So this is not something theoretical. It's something that can, with actual code, that can be done on the network today. So the remaining task, what we are doing here, because we show it, but it's, of course, it's not very easy. So we need to build even more abstraction on top of it. Maybe it have some SDKs and all libraries to further simplify the program developer's job. So that's the first one. I would say is stateful, to maintain state inside smart contract. So this is very powerful because, you know, if you can maintain state, basically I think some people even ask me on Twitter, so if this is possible, why do we need Ethereum or EOS? I'm saying is I don't have a good answer, because if we can do everything they can do and cheaper and scalable, it's very hard to argue why they are needed at all. But of course, we need to have more tools to help even simplify this job further. Do we have questions here about this? I can just continue. Anybody have any questions about?
Any questions here? I'm just going to admit one more person. Hopefully the person is reasonable. I'm not sure who it is. I'm just going to point out as well that what he's saying, that it's got amazing business opportunities. The things you could make use of that for businesses in mortgaging, in loans, mortgages, in actual purchases as well, where you have people waiting and then you wait for another person to input and then you continue on the state. It's got some brilliant potentials. So yeah, excellent. People should look at it more. Questions, anyone? Or we'll continue?
So far? Anytime you can just say in the chat, or I don't know how this works, but
there's nothing in the chat so far. I think they're just absorbing everything you're saying, finding it interesting. So, yeah. Have you had many people ask about Scrypt yet? Have you brought it further out? What stage would you say development is at? You were just saying it needs to be built up a bit more developer friendly, or?
I think, yeah, for now you can start playing with it. I think some people are already playing with it. Like, of course, the last example I'm going to show, the serious articles, not by me, but by Stas. I think he's also in the ICU. So basically, he's very passionate about this. So he kind of like combined all my examples together and put a very, I would say, is the most powerful Bitcoin contract today. So basically what he does is so basically I have here is all primitives. So for example, I have this way to maintain state and to read the current transaction. So the next one technique I introduced here is the so-called wrapping signatures. So again, wrapping signature is also a very nice technique that introduced by Unchained. So basically, I take that and implement it in the high-level language and wrap it in the library. So what the wrapping signature enables you to do is to have the capability of an oracle, because a lot of times, right? For example, even within Scrypt, you can read the current transaction, but if it's anything outside of the blockchain, you are not aware, right? Let's say today's London's weather, I don't know, or today's BSV's price, right? So a lot of time you want to retrieve some information off chain. So the way to do it is to have oracles. But oracles, they have to make sure the data first is authentic, right? They need to sign it, and also by signing it, they also make sure it's not tampered with, right? So you don't want somebody to intercept and change your data. But the typical way to do signing is to use the so-called ECDSA, as we already use in Bitcoin. So the problem with that is there's no way, because I think most people here, if not all, have been to BCH days. So one of the reasons we split is because they insist we have this opcode called DSV, right? Data seek verify. So that can verify, you can verify a signature for any upstream data, because we don't have that opcode for a lot of good reasons, I think. And for now, we have another good reason, because we don't need that opcode to implement it, right? So since we don't go that way, so basically we can think using existing opcode, you can combine it and do the same thing, and it's even better. I can say a few things later, but so basically you can think of this kind of similar to that opcode, but using existing opcode from the original Bitcoin script. So basically, then now you can introduce any arbitrary off-chain data inside your contract. You can access it. So that article is called wrapping signature. So we have some examples over there. You can sign it and verify it on chain. So basically, the way it works is the signing part is, so whenever you want to retrieve some data from an oracle, the oracle puts the data inside, push it in the unlocking script and sign it. So in the contract, you verify, okay, does this data actually, is it actually from this specific oracle by doing the signature verification. So once you have that data, you can do a lot of things, right? So let's say you can have a futures contract, can have a foreign exchange, right? You can even do cryptocurrency trading. So that's also another powerful primitive. So with the example.
Sorry, can I'm just going to quickly explain the oracles for the viewers and people who are watching. Oracles are basically outside programs which are not on the blockchain itself, but interact with the blockchain. So you can have something written up which will interact with an oracle. An oracle will check and mix with whatever your program is. So say my basic example is a gambling oracle. You might have, say, 10 gambling shops, each with an oracle. You make a bet on the blockchain, and the way you've done it is that 7 out of 10 of these gambling things must agree. They're all oracles. If 7 of them agree, and using something like Scrypt can actually get this working. If 7 of them agree, and then you win, and it pays out. And it might be in such a way that the first 7 that agree get a little reward and get paid as well. So it's useful being an oracle. So sorry, back over to you.
Yeah, good explanation. Basically, it's a way to get information data off chain to let the contract know things off chain, because in general, you cannot do it natively. You need some kind of like a third party.
So, Tones, do you want to speak, ask the question, or do you want to type? I'll unmute you 1 second.
Okay.
Hi.
Oh no, wait.
Sorry,
ask again. I ask again. I double clicked it.
Yeah, I was like, okay.
So I'm working on my own library, which has transaction creation capability, and I can handle all the standard opcodes. But what I don't have is high-level operations. I don't have a Raven signature function.
Okay.
And I've installed your extension in Visual Studio Code and played with it just a tiny bit. But
okay.
what I don't see is how, if I got an example of what I wanted to do working in Visual Studio Code, is there a way that I could create something that I could then link into my own code that would take some arguments and then generate, the opcodes? So I would imagine I'd need to give you some kind of hooks to say, okay, if you want to emit an opcode into my environment, call this method.
Yeah, actually, you can do it today. It's a little bit of you have involved a little bit of actual work. So basically, I have this compiler, so I also release it as an npm package. So basically, you can go to npm, you search Scrypt C, means compiler, so you can find it. So basically, it's an npm package. I also have some. For now, it's like a command line. It's a CRI. I think maybe later I can add a little bit of thing wrapper. So basically, you give it source code, the contract, you just bring out all the opcode. Does it make sense?
Okay, so at a CLI level.
Yes. I think it's very. It should be very easy to add. Let's just thing wrapper, like another back. You can just bring out whatever, take the output, and just output whatever format you have. And also I have some examples. I just shared a link. So basically this is the repo for Scrypt. So basically I have some examples. You can also check in. It's also mostly in JavaScript. I also have the TypeScript bindings as well. You can, mostly in the boilerplate repo, you can check the way how do you compile it and how do you put in a transaction and broadcast it.
Okay. Do you have somebody who's integrating this right now in kind of production code?
I'm not aware of, because this is still very new. I think the IDE you remember. I just released it like 2 months ago. Now it feels like many years ago. I don't know why, but it feels like a long time ago.
Okay. And one last question, if I'm not monopolizing too much. I've just been working on the merchant API, trying to figure out why, I guess there are 3 endpoints that were published in Unwriter's library, and for me, 2 of them would never accept a transaction. Finally got that straightened out, so all 3 of them now will accept transactions.
Okay, cool.
What I haven't tested is how complex they're willing to accept. And I'm wondering if you have some advice on who will take, kind of push the limit.
What do you mean?
So if I were to try to use a Raven signature generating script, who would take the transaction from me and mine it?
For now, I think the complexity is not an issue, because you remember we used to have this notion of standard transactions. Basically, you only have 5 types of contracts.
Okay, so you're not pushing the limit.
Receive. as long as there's only a limit of size. So if I remember, it's like, I forget, I think last time it's like 10K or something, 10 kilobytes. If the script is less than that, most miners will be good. If not, I think you have to contact individual miners like mempool or tau.
Right. So tau, matterpool, and mempool are the 3 merchant API early adopters. So they've all published an endpoint to push a transaction.
Yeah.
And they've also got an endpoint for estimating fees given transaction size.
Yeah.
So you can almost automate the selection of who to send the transaction to.
Do they have like a Scrypt limit information there yet or not yet?
Scrypt image?
Scrypt limit, like size.
No protocol no API for getting the script limits.
Okay. I think remember it's like a 10K, but it's like it's a policy, so it's not a consensus rule. You can always contact some miner and say, take my money. I wouldn't be surprised if they take your money. I think if it's usually it's lower than 1 megabyte, you should find somebody. But it's bigger than that, maybe a little bit issue. But if it's only tens of kilobytes, usually that's also already very big. I think if you look some examples, usually it costs like just hundreds bytes. That's it. It's also considered very complex now. If you manually write a script, that's like hundreds of code. It's like crazy, right? So. Yeah, you can always ping me if you have issue. I think I broadcast some on testnet. On testnet, you can broadcast like I think the last one I tried is like 50 kilobytes or something of pure script. So that's already big.
Yeah, I'm very interested on what will work in a production context today, so that if the things that I build, if I release them, people can start using them as soon as I release them. So I'm trying to make sure I understand the whole pipeline.
Okay, cool. What are you working
on? I'm building a number of interoperating wallets that do things, accounting, taxes, funding between wallets, and payment automation. So none of that is probably yet in the complexity range that you're talking about. But persistent digital objects that allow for selling ownership and controlling who gets to update them is about as far as I'm thinking complexity-wise. And I don't know that I'm pushing what I would really benefit from Scrypt yet.
Okay.
But I'm interested in what the tools are capable of. So Scrypt is definitely very interesting.
Okay, cool. Yeah, keep an eye. I think the easiest way for now, if you think about just if you have Ethereum or EOS experience, so whatever they can do, we can do it better. It's the easiest way to.
Never touched Ethereum.
Oh, okay. Good. That's good. Waste of time. So save time.
Okay. Thank you very much.
Okay. Thank you. Good questions.
There's a question in chat, but I'm not sure if you're going to be able to answer this one. Is the miner API going to add script runtime into the fee estimation requirement?
Oh, yes. So the way for now is you can think of it as like, of course, right? The miners, I think recently we also have tau, right? They reband them instead of saying, oh, we're a miner, they say, oh, we're like transaction processors, of course. So as these contracts mature, more people use it. So another big revenue for them is to process it. So of course, if you send like a normal money transfer transaction, that's probably cost much less than when you run a, like say, futures derivative contract on chain, right? Because there's just more processing and storage too. So for now, because we're very early, so I think the fee is still based on the size of the script, right? So you can think of more complex, the more processing your contract have, the larger size. So it still is proportional, is based on Satoshi per bytes, right? So I would imagine going forward, also we have a lot of discussions in the ICU channel based on what will decide how much fee each transaction will cost. for miners to accept it. So I would imagine this something will be more flexible, because for now it's all simple, right? We just look at the size, but the size doesn't tell you everything, right? So for example, easy example. So if you have 100 opcode, if it's all op1, there's probably much less processing involved. It's all op-chap-seq, right? So I would imagine there will be, I think in the channel, people are talking about it will be decided about the market. It will be decided by each miner will have their own fee calculation. Let's say, oh, how many op-chap-seq you have and how big is it? Combine this. It'll be very interesting to see how this fee rate market evolves.
I'm going to highlight quickly about how TAO's recently renamed. They're no longer in the block mining industry. They're now in the transaction processing industry, which,
yes,
aligns perfectly. And yeah, I'm going to highlight how we used to discuss this, how complicated Scrypt languages, will cost more. But when you can do really complex scripts, you'll be able to do programs. Everyone in the last 10 years, BTC and BCH and F and all that, they all got kind of stuck with moving money from A to B. Whereas as has been explained, and is being explained, Bitcoin is so much more. And so is MetaNet. Yes.
Why do you have Scrypt? It's like, I think some BCH people used to argue with me, oh, it's only for cash. It's like, why do you need Scrypt? Why do you need all push data for, right? So
we are building the future. It's not just going to be absorbing the internet, but also writing programs where businesses can conduct business using Scrypt language, higher programming languages, which it won't be called Scrypt later in the future. It would just be called Scrypt or whatever the compiler has decided to, name their higher programming language. And everyone will forget about Scrypt language in a few years' time. It would just be all the different higher programming languages. So we are very early days yet. In around, I reckon, a few years' time, there will be, your compiler will be complicated enough, and others as well, where people won't bother remaking compilers from the base script because it'll all be done. So we are very, very early days, and as I was saying earlier, we have a leader here who isn't following; he is a leader.
Okay. Yeah. So I think if you remember the last CoinGeek London, so basically Steve Shatters, he went on stage to say, oh, if you want to be the next wave of engineers, software engineers, you better get familiar with Scrypt. He says he has this big open call for future Scrypt engineers. So I would say at that slide, he lists, today we have 0. So that's why I have a little bit of argument with him afterwards. I say, okay, I'm doing mostly Scrypt every day, so at least that's at 1. I think the number is definitely positive. So he kind of like, okay. Yeah. So keep going with recent articles. So once we have the first example I have is once you have a state, I give one example, which is people haven't thought about it. I think it's very interesting, is how to implement tokens at layer 1. So in general, I think we have a lot of tokenization protocols. Even in BSV, we have Tokenize, we have RON, we have Bitcoin Computer, and even before BSV, we also have like a BCH, BTC days. They also have like a color coins and SLP. They have a lot of protocols, but all of them you can think of is not run on natively on Bitcoin. So basically, the token rules is not enforced by miners. But here I kind of show is another way to implement tokens within layer 1. So basically, it's like a Ethereum or EOS. All their tokens, they are enforced by the miners. So if I issue, if the transaction go through, then I'm good. I know this is a legit transaction. But for layer 2, the layer 2 is basically you just put the metadata. Let's say, oh, what format of what protocol ID I use, what kind of format I use for the tokens and the balance. So basically, but it's only data part that's put on chain. They're kind of like a use as a database, but it's not using the rules are not enforced by miners. So they have to enforce by some third party other than the miners. As for example, if you are tokenized, you can have spin up your own node, store all the data, all the transactions, all the transfer, and so later you can check, you can read from all the blockchain and check all the rules are followed. By that, you can have the tokens either revoked or transferred. But here, everything is done on chain. I'm not saying this is the way to go, but I just give you a very good alternative. Some use cases, I think is better suited for layer 1, or some other cases, definitely that's the case for layer 2 as well. So I'm basically not arguing, oh, this is the only way to do it. I'm just showing that's another way to do it on layer 1. So depending on use cases, you can decide which way to go. Okay. Any questions about this, the layer 1 token? Is that?
Anyone? No. We're after the article.
I send it. I think I also shared the first one, but let me send it again.
And I have a question for you from the chat, which is, what's the main difference between layer 1 and layer 2?
Okay, pros and cons. Okay, good, very good question. I think a lot of people are asking me. So layer 1, the idea is more so-called, if I can use the word, trustless. So basically, if I send a token and show that, it gets mined. It's like a layer 1. You can think of the security model is like a native Bitcoin, right? So when I send you Bitcoin, you check it can be zero confirm. If it's in a blockchain, you're good, right? You know this is legit transfer. Okay, but the layer 2, the same with layer 1 tokens. So if I have a layer 1 token wallet, you have a wallet. If I send it to you, you see the transaction, you can be zero conf. It's like almost like a security model is the same with native Bitcoin. Versus layer 2, layer 2 is how I do it. If I have a layer 2 wallet token wallet, and you have one, I want to send you, let's say, ICU tokens. Let's say Joe, he issued some tokens called ICU tokens. So I'm not suggesting, but just hypothetically, if you have some such tokens, if I send it to some ICU tokens to Joe, he has to, even the transaction is accepted, you cannot be sure this transfer is legit. For example, if I only have 10 tokens, I'm sending him 100. For that case, that transaction can also be accepted by the miners, because for them it's just raw data. It's just there's no logic. It's just data return of data. Doesn't matter. It doesn't enforce the token rules. So for that to happen, you need some layer 2, the so-called layer 2. Basically, it's some other third parties other than the miners. They have to run their own token validation on top of the layer 1. So that's why it's called layer 1, layer 2. So of course, the con I just showed is layer 1 is more trustless. So as long as the transaction is accepted, you know that the transfer is legit. Okay, it's like Bitcoin. And layer 2, but the problem here is, it's not a problem, I would say it's a feature. It's more, it's harder to control, right? For example, if I mistakenly send you some Bitcoin, it's very hard for me to reverse that transaction, right? So if you have a layer 2, so basically even you get mine, but if the issuer is validating all of them, you can revoke it, right? So basically you can have more fine-grained control. You can reverse, you can revoke, you can blacklist. It's much easier to control. Does that make sense? I'm not saying it's a pro and a con. It's as I said, it's all based on your different use cases. For example, you just want to issue a token, you don't want some third party to to have arbitrary rule over this. It's better suited for layer 1. But if you will say you want to have if you're issuer, you want to have full control, probably there's I would say layer 2 is more suitable for that case.
Just going to add in that banks and governments would find it very, very interesting, because it is the key thing about retaining control. And a business and a bank and such, whereas another time we talk about the alert key and whatnot, but barring international agreement to reverse a transaction or reverse whatever, as a business in a singular nation, if you want to have control, say maybe you're selling cars with electronic keys and someone's had their car stolen, and you need to revoke that electronic key which unlocks that car. This would be perfect for it.
Yeah, code is not law. So if I lose my car keys, I don't know about you, but I prefer not to lose my car in that sense. Depending on your case. And also you can build even in layer 1, you can also build such mechanism. So for example, right, it's not, you can also bake this regulation or compliance into the layer 1 tokens as well. For example, you have let's say, if I send this, every ICU token I send, I need the Joe's signature, right? So you can also put this in the contract itself too. It's similar to what you can do layer 2, but you can also bake this logic into layer 1 as well. Does this make sense?
Just to say for every listeners, then, so it would be a case of, say, if I wanted to issue some ICU tokens and such, but I wanted them all to be signed by me to be valid, just in case someone else wanted to try and flood the market with them and cheat. So that anyone buying the ICU tokens, they could check to see if they've got my signature on it.
Yes.
And then they would know that's valid.
Yes, you can put this in layer 1 as well. That's what I'm saying. You can let's say, as long as this transaction appears in the network accepted, then you know this transfer is legit. Versus you can also put in layer 2, but then you need, even if it appears it's get mined, you are not sure. You have to rely on a validator on top of the layer 1 to make sure this is legit. Limitations.
I have a question from chat. Can you please explain the limitations? For instance, how many L2 tokens can you create within a layer 1 Satoshi? So basically, are you going to need a lot of Bitcoin if you want to do a lot of business, or can you do it within a small amount?
I think there's no practical limit. I would say it's like you can, let's say Joe wants to issue some ICU tokens today. It's the amount. Whatever amount he decides, he can be 1 trillion, 21 million. In that sense, you can put whatever, how many tokens. There's no practical limit. I think the only limit here is, I would imagine, because it's more trustless. It's basically, as the miner takes it, you know this go through. So probably some of them the computation, because the validation is done by the miner. So you probably pay a little bit more fee, because not only, so think of a layer 2 and layer 1, what they have in common is the token protocol consists of 2 parts, right? The data part, you can think of almost like a ledger, sub-ledger, right? So the data part, of course, you put on chain, whether you use layer 1 or layer 2. But the difference is the validation, the check. You do layer 1 or do layer 2. So because the token, layer 1 token do everything both in the layer 1, so probably you have to pay a little extra processing, but then they give you more trust. If it goes in, it's good. So there's no simple answer is there's no practical limits to what kind of tokens you can have. And of course, the good thing here is, I mean, we have already know the Ethereum, right? When you have some crazy crypto kitties or crypto whatever, you can get slowed, right? And the fees get high because they cannot scale. The good thing is you can port whatever they have here. You can do the exact same thing in layer 1 because we can scale. So it's much cheaper. It will never get congested. So that's a part. That's why when we say we will make some other chains as our sub chain, it's practical today even, and cheaper. You can do anything they can do. So not only the data part, but also I'm showing through this series articles, also the complex contract as well. Hey, Stas.
I'm just going to, hi Stas. Generally when everyone joins, they're muted, but if you want to ask anything, I can unmute you, or I can, or type in chat if you haven't got a mic, and I can repeat anything you say.
Hey man. Yeah, I think if I can keep going. So if any other question? If not, I go to Stas' article. Oh, maybe Stas, you talk about your article. Do you want to do that? Your fancy smart contract?
I'm not sure if he's got his mic on. There's no mic symbol by his.
Okay. If not, I can get started. So basically, the last one is basically I introduced a few primitives in the serials articles. For example, op push transaction, and you can do tokens. You can do maintain state, and also you can using rapid signature to get off-chain data by oracles. So Stas showed like I would say the most powerful usage of combining all of them together. So basically, you need a rapid signature because he's using a smart contract that can help the farmers to hedge against the risks. For example, right? If any farmer, you don't know what's next season's weather look like. You are growing some potatoes, and then so you want to usually hedge it through this financial instruments. And so he showed one, which is the futures insurance. So basically, the idea is you keep paying premium in this smart contract, and then when the time arrives, let's say next fall, right? Some authenticated oracle, they are going to put the weather data, either I think from a lot of sources, you can say from a weather SV, and he also showed another interesting way to using the Raspberry Pis to gather local data. So you can put the data on chain, and then depending on the weather conditions that you have decided upon, whether it's the temperature and how much rain, it can automatically settle the contracts. For example, if the weather is very good or you have premium, then the insurance company can take all the premium, right? That's good. But what if the weather is not bad and your crops all rot in the field? You cannot sell. You don't have a good harvest. So what happens in that case? You, as a farmer, you can get the cover, right? So basically, a certain term of payment you can get from the insurance companies. You can also take it. And the good thing about this is everything is automated on chain. So you don't suffer from the usual problem of doing it off chain. So basically, first is you don't need to trust anybody because everything, the contract is enforced by the miners, right? So you cannot easily cheat. Second, because everything is down, the smart part coming because everything is automated. So of course, I would imagine that can also save the cost of doing this kind of a business. So that's a very good example of here. Combining, I would say, all these primitives and putting a real practical applications to demo what kind of things can be achieved. Any question about this article? I think I have sent it. Let me send it to if you have not read it so far.
Yep.
Any other questions?
I was just going to throw in that this topic. Oh, Stas is back in and he has his mic. If you would like me to unmute you, Stas, if you have any questions or want to add anything, please let me know. I was just going to throw in that this subject with higher programming languages on Bitcoin. Bitcoin is a programming language, basically. It's so big and complicated that we're going to be doing a few of these over the next few months. We host one meeting a month. I'm going to be talking more with people to, we're going to do some screen sharing in future, I hope, and we can show some simple little examples and get people a little bit more involved. It covers such a variety of things, as food, stock, gambling, housing, cars. It depends whatever you apply it to. Hey, Stas. Stas is here. Brilliant. Any questions, anyone? You don't have any questions? We are almost to an hour, so I don't want to burn you over 1 hour because we'd like to keep people interested. And I'm also going to, actually, I'd like to ask you now, if people are watching, are really interested in this and they want to learn more, how can they get hold of you? How can they reach out? Twitter and...
just the best way is, of course, why I like ICU. So I think most people joining here probably they know, if they're not in ICU, they probably know somebody in ICU. So yeah, that would be great. Actually, I'm actually still actively looking for more funding. So I have a very good fortune to already have 2. So Kevin Nail and Kanshido. So also he's in the Slack. So if I don't know, it's if you want to see this happen and help, that will definitely just contact me in the ICU.
So everyone whoever watches this outside of MetaNet ICU, you can contact if you join the ICU, or if you don't want to join the ICU, you don't have to. You can reach out either via Twitter or Reddit, and you will hear it. We will hear it, and we will pass on the words if you want to get in touch.
Okay, that'd be fantastic. So by the way, I'm not issuing tokens, so it's real. So.
Right. Does anyone have any more questions then?
That doesn't have to. I mean, just anything. For me, I would like to ask a question to all of you. What kind of contracts you guys want to have? That's not people are not developing today. Parisa, probably you have some ideas. Stefan, what kind of contract you want to write, or you want to see others to develop? Any
Stefan? Anyone? If you would like, I can unmute you. If anyone's going to...
Parisa probably has some good ideas.
Anyone? Types of contracts you would like to be written in the immediate future? Things you are interested in looking at?
Maybe Parisa, start with him.
Parisa, okay, I have a question here. A perceptron reading data from the Oracle of Stas.
Okay. Poker. Okay. On-chain, peer-to-peer gaming. Yes. That could be a big one. Yes. Does anybody know the first version of the? I think Craig said he built a poker in the first version, the first free version of Bitcoin.
The initial idea behind Bitcoin was to build a poker online thing, and just have a poker room. And he actually had built a poker room inside Bitcoin. I've seen a picture of the UI.
I've seen the picture, but I've never seen the code because
no,
the V0.1 it's all. I don't see poker, but that would be. Yeah. It's just for payment, or do you know? Is it the purely on chain, or what is this?
I think it was purely on chain, like just for players and payments and such.
Okay.
Just to answer Konstantinos, yes, you asked a difficult question. The perceptron. That'll probably come a bit further down the line.
Okay. Yeah, he wants to do AI on chain, so that would be definitely something
definitely
difficult,
doable.
not trivial. Yeah, that's what I'm saying, the poker. But I don't know much about this. I think I see some pictures, and there's also a marketplace, but I never see what is actually do. I don't think it's purely fully on chain, right? At that time. Okay.
No, he this is part of the reason why he disappeared for a while, to go and work on the marketplace and other stuff and the Scrypt language, and to play with like what could be done. But unfortunately, then, as we all know, the core lot started breaking the Scrypt language and taking out the opcodes. So, and he did try and convince them, I believe, to stop breaking things, but yeah, they didn't listen. Yeah, it didn't go very well. like you were saying earlier with their Ethereum lot and such, you know, he was saying, yeah, this can be done, that can be done, and we're like, no, it can't, we're just going to take it out. And they didn't even try. So
yeah, just disable all the opcodes and put the block size to 300k, right? So
yeah,
pretty much.
And we have one from Bitcoin Stefan, a bounty system which rewards developers for fixing bugs and other software issues. Would something like that be possible?
Yeah. I think somebody has. Have you heard about Coda? Basically, one of the hackathons, they are doing similar. They're not putting bounty to fixing bugs. So basically, it's a way to monetize your APIs. So if you write some big, very good programs, somebody else to take a course, you can charge micro payments. I would imagine, I think this is a little bit a future oriented. I think for the API, and also imagine now you have a global computer. It's not the Ethereum unscalable global computer, but think about Scrypt. It takes about the computation part of the Bitcoin. So basically, for now, most of the, if not all the apps, are using this as a database, right? They store data, dump raw data in op return or whatever. So basically, you use it as a database. So now, through Scrypt, and specifically for me is Scrypt, you want to see this as a computing part as well. Not only the data part, storage part, but also as a the real computer, you can process things. So one contract I'm thinking about, I haven't figured out exactly how it works, is basically you pay per computation, right? So whatever computation you want to have, for example, you want to find some optimal problem like a traveler salesman or graph coloring or folding some protein, you want to find some computation. So basically you put it as a bounty, it's a marketplace, but for computation. Whoever can solve this problem can take the money. And this is down peer-to-peer way. For example, I'm a fan of Sudoku puzzles, so I want to solve this Sudoku, but I don't want to figure it out. I just say, oh, let me send this transaction. Okay, this is my board, and whoever comes up with the solution, he can take the money, right? So any computation can be done in this way. So that's, I think it's a little bit into the future, but I think that's how I see this thing can evolve. Basically, you can not only the Bitcoin network become the global database, but also become the global computation computer, the real computer. Basically, we all have like kind of like a SPV at our end. Anything that's a little bit intensive, we just say, oh, okay, you want to do it, you can just pay. And all the miners, the so-called transaction processors, they can compute. Whoever get the lowest rate or who can solve this puzzle. Yeah, it's a global bounty. So whoever can solve this most effectively, he will win out, right? He will earn more profit by solving all of this. So that will be very exciting to see. That's how I imagine this thing going on. So basically, every computation, one kind of contract is whatever computation you want to have, you put in your locking script, you specify the spending conditions. Then you verify this solution is right. Then whoever can offer a solution, he can take the money. Nobody, he doesn't have to know where you are, who you are, and how competent, and doesn't matter. It's a global marketplace for computation to solving problems. But the native solution is it has some problem, right? It's like a hash puzzle, right? So if you put the pre-image, the miners will see it, or anybody who's relaying this can see it. They can steal the puzzle, the solution, right? Then he can take the money. So there's still some minor details I think will be figured out, but I would say this is, if this can be done securely, it will be very, very big.
I'm going to touch on identity management as we're past an hour, because you've mentioned a few things earlier. I didn't want to say it at the time, but identity management is a kind of next step forward for Bitcoin as a whole, for the wider world. We have PayMail now, which is, as most people know, it's a unique identifier, a static identifier on top of a variable. PayMail by itself is not an identity, okay? But you can use it to do, identity management can be done in different ways, multiple different ways. One of the ways of doing it is just having identity tied to the PayMail and such, and you verify it as a business. But what I would like is that if people who are interested in this, go back and listen to what has been talked about. You can use Scrypt with identity management and PayMail, a combination, to allow you to have PII, personal identifiable information, up on chain in such a way where it remains, it can be verified by a business or by an authority. Authority can use, sign your uploaded ID and such using Scrypt in a certain way where your identity will be verified by the business authority, and then you can use that identity in further businesses or for mortgages or for whatever else, if it's accepted. But the trick is using Scrypt. You can do some cool things with that, very cool things. So if people are interested in the identity management side of things, I do suggest having a bit of a look. Sorry, back over to you.
Okay, identity part?
Well, identity management, and I'm going to let people try and figure it out a bit because I don't want to spell it out completely. But there were things we were talking about earlier about allowing others to sign and verify, say like a token or something. But this can be also used in identity management as well, and is very useful for identity management because you can't just upload your own ID and say this is me. You need an authority or business to take liability for that identity, for a person's identity. But using Scrypt, you can, and a combination of Scrypt, a PayMail, and throwing in identity management, you can have a business or an authority verify that you are who you say you are, whatever you have uploaded and such. And it's a very, very useful tool for that. Identity management is going to be a thing for this year, coming up later this year and next year, because when you have identity management, you can then move on to things like peer-to-peer lending, house share ownership, shared ownership of various other things like lawnmowers, cars, or businesses and whatnot, if you have identity tied back to that. But you need, Craig was talking about it the other week, about different stuff on top of Bitcoin, because Bitcoin obviously isn't the end all. You have Bitcoin, you have MetaNet, then you have like PayMail, different protocol, then you have Scrypt. Unfortunately, I wish I had my stuff, my markers, then I could really draw it out. But Scrypt, the way I see it, is a foundation, one of the foundational supports. You know, you can have PayMail, you have this and that, but if you don't have something like Scrypt, it's just going to, identity management collapses. But with Scrypt, you can actually create, yeah, like I said, keys and such where people have to verify and confirm and also revoke, which is extremely important on identity management because of fraud and people changing addresses and changing your ID and whatnot. It's extremely important that an authority or business is able to revoke XYZ identity and apply a new one for you. Maybe you change a picture or you've grown a beard or something like that. So
yeah, I think most of us has grown some more beard and hair. This is the longest hair in recent years because I cannot go out get a haircut. It's all closed. So okay, it's enough ranting for this lockdown.
Right, I'm going to ask people to throw forward some last questions, and otherwise we're going to be ending soon. And we will be continuing and picking this up another time. Any more questions, anyone? Nope. In that case, do you want to say any last words to the viewers?
Oh yeah, thanks. First of all, I've been in ICU for quite a while, and I enjoy a lot of companies over there. I think it's kind of a very small circle of, I would say, the like-minded people. I think even for now, I have some controversial opinions about everything going on. I feel it's kind of crazy world out there. So it's good to have people to connect. I think this is a very few. I think even for people around me, if I say this is overblown, I think most people will not agree. I think I'm crazy. And that part, I think it's also good to have, whenever I have some idea, I just want to brainstorm a little bit, and just, this is one of the best platform because I would say this is, if not the, I think okay, let's say, I think this is the #1 place for Bitcoin experts together. I just said it, so forget about N-Chain and other people, but I think this, at least for the Scrypt size, I think this is the top experts are in this, all of them, I would say, are in this group. So it would be very nice to now invite here to brainstorm ideas, and together, I think we are all in this together to see, we all want to see Bitcoin grow and be professionalized. We want to see, and also collaboration ideas. So basically anytime, if any idea or any questions, I would, if it's Bitcoin Scrypt, is just feel free to ping me anytime. I think it would be, we can talk.
Thank you very much. It's been a brilliant talk and presentation. If you could all stick around for 2 seconds after I stop recording. Thank you very much, viewers. If you have any questions or so, reach out to us via Twitter or Reddit, and we will get back in touch with you. I'm stopped recording now. Thank you all.